Hey guys, let's get started for today. So we will be starting with Kubernetes today. Now, the first thing is, why should I go with Kubernetes and why should I learn Kubernetes? Now, the first thing here is that when I start my containerized world, okay, I will start from the very beginning, like where I started from and all those things, okay? So long back somewhere when the IT itself started, we were using big machines, mainframe machines, one single big machine which will host everything. So we were dealing with monolithic applications. So monolithic. So initially when we started, our applications were like this. One single machine, and on top of that machine, you had everything. Okay. But the problem with this kind of a setup is that when you have everything on one single machine, connectivity and all is okay, that's okay. But the problem starts when one of the component goes down. Now assume that one of the components is down. So what you have to do is you have to bring down everything, make sure that everything is fixed, and then you put everything back. Okay. Now, in this process, when you are putting everything back and you are doing all the work, meanwhile, you will have a problem. There will be something called downtime. Now, downtime is the time during which the application is not available. Now, the application is not available, so you cannot do business. Now, let me say you are a cab service company where people book cab. So people will not be able to book cab. If you are a company like Netflix, you will not be able to stream anything. If you are a company like Amazon, then you will not be able to sell anything. So even if 1 hour, 2 hour, 5 minutes, whatever is there, it is impacting your business. So there are three major things which I am looking at. Point number one, I'm looking to maintain high availability so that at any point of time, if there is a failure, my components go down, still I am online with minimal services, but still I am online. Then the second problem which I'm trying to focus here is that auto scaling, load balancing, and container orchestration. These things should automatically happen. Now, where is this container and all coming? Now, what we did is we moved from a monolithic architecture to a microservice-based architecture. The moment we move to microservice-based architecture, we start dealing with a lot of servers. You can see here, I have like 4, 5, 7, 8 microservices. Each microservice represents one functionality. So I showed you that when I go with Uber is nothing but it's a cab service, right? So the moment I go with this cab service, I can see that there are multiple components inside this. And these components can independently exist, but they work together as one single unit. But if I have to go and fix this, or if I have to work with a microservice-based architecture, I will need a container orchestration tool because each microservice is working on one container. Now, this is also done. Okay. This is also done. Now, each microservice working on each container, and hence I am using these containers. And each container has now to be managed. Now, who will manage this? So to manage these containers, I went to Docker Swarm. But the moment you go to Docker Swarm, you will see that Docker Swarm is not that effective. Why? Because load balancing, auto scaling, everything I have to do manually. And I don't want to do them manually. Second is that the tool Docker Swarm is not production ready. So when we say production ready, It means it is not ready to take production load. Even if companies tried to put the production load on Docker Swarm, it has failed. So I showed you the other day that Docker Swarm is almost negligible. Nobody is using Docker Swarm nowadays. Everybody has migrated to Kubernetes. Now, why Kubernetes and what are the benefits? So Kubernetes comes from a product called Borg. So Borg was a tool which Google had developed, okay, and they were working with this tool. They were not doing container orchestration, but they were doing a similar kind of work with Borg. Google saw that there is a huge opportunity in this market. So what they did is they came up with a new tool, which was called as Kubernetes, and it was based on Borg. Means inside Kubernetes, the code which they had written was Borg. Okay, they just renamed it. The moment they presented this, they also made it free of cost. So if I come here and say Kubernetes, and I go to wiki. So here I can see, let it come up. So here I can see the original author is Google. If you go inside, you will come to know that originally it was named as Borg, then they renamed it to Kubernetes. The developers or the people who are maintaining this is my CNCF. CNCF is Cloud Native Cloud Foundation. All the tools which are free of cost, open source, are managed by this organization, CNCF. It was developed somewhere around 2014, but it was not that popular until 2018. In 2018 and after onwards, it became seriously very, very popular. This is the official GitHub repository of Kubernetes, GitHub Kubernetes /Kubernetes. Any update will be here. It is written in Golang or Google language. As I told you, it was a different product. It has been customized. So it is written in Golang, and it is a container management software. Okay. Now, what do you mean by container management software? So if I come here and say container, or if I simply come here and say orchestration. So orchestration doesn't mean that there will be someone sitting at the center and he will be managing everything. So kind of master slave architecture where this guy is the master and he is managing these worker nodes. So Kubernetes also works on master slave architecture. There will be masters and then there will be a number of worker nodes which will be doing the work. Then why or what happened in 2018 that Kubernetes became so popular? 2014 it was there, 15 it was there. 2018 what happened that it became so popular? So there was a game called Pokemon. So there was a game, mobile game, Pokemon Go. Now this Pokemon was using this particular software, Kubernetes. And this software was really a big hit. There were millions and millions of users around the globe. And not a single incident was reported or it was known where Kubernetes was not able to handle the workload. I'm talking about millions and billions of users all across the globe. Not a single instance where it failed. From there, it gained popularity. And if you want, you can read the use case. They'll tell you what all happened and all. But in case you're interested, not something to just know. But in case you know, in case you want to know, you can go ahead and read this. So Pokemon Go was a tool which inside that was this guy running, Kubernetes running. And from there, Kubernetes gained importance or it gained the market. And then nowadays, everybody is looking for Kubernetes developer because it's a hot skill and limited resources are there. Those many resources are not there. So after that, what happened? So after that, everybody started using and there is a good crunch or good shortage in the market for Kubernetes developers or Kubernetes administrators at all levels. Now, if I have to start learning Kubernetes, this was all about history. But if I have to start learning Kubernetes, what should I do? The first thing is I should know where to start from. And to where to start from, I should know what's the architecture looks like, or how will it start the work. So let's come here. I have the architecture of Kubernetes here. Now this is the Kubernetes architecture. Now, if I come back to this guy, wait a second, let me take a question. Is there any benefit of learning Docker Swarm? No, Docker Swarm, I personally feel there's no benefit. You can just know for readability purpose, but there's no benefit of learning Docker Swarm. There is no use as of now. So if I go to Kubernetes, this is what I can see. The Kubernetes runs under master-slave architecture. Now, what is master? What is slave? So master is the node or machine which will manage all the clusters. And worker is the node which will actually do all the stuffs. So if you see carefully, master is just managing and worker is doing the actual work. Now, this is my master. So generally what happens is we say Kubernetes cluster. When we say Kubernetes cluster, it means it's a combination of master and worker node. Okay. So many times you will hear people saying Kubernetes cluster. So whenever they are saying cluster, it means they are talking about master and worker node both. In master node, they have these guys, also known as control plane. In worker node, they have these guys. I'll explain each one of them. Give me 1 second, guys. Okay. So in my master node, I have these things: my API server, scheduler, control manager, and etcd. And in my worker node, I have these things: pod, kubectl, and kubeproxy. Let's go one by one. So this is what I have. I have Docker. Docker is nothing but my master-slave architecture. And there is something called cluster. So whenever I say cluster, this is cluster. So whenever I say cluster, it's a combination of master node and worker node. Now, there is a very common question which is asked here. In your production scenario, how many master nodes were there and how many worker nodes are there? So the first thing is that you can have any number of master nodes and you can have any number of worker nodes. So how do we decide how many master nodes are there and how many worker nodes are there? So it will totally be on the workload. Suppose my company is running a lot of things. So the number of master nodes and worker nodes will be more. But if there is a small organization, it is not running many things, then it will be less. Minimum, if I say minimum will be Minikube. Minikube is in one machine only, I have everything. I have my master, my worker node, everything I have in that machine only. In case you want to install Kubernetes, okay, and you want to get started, you can go to this place and you can say Minikube. So Minikube can be downloaded. It can be downloaded at your local machine. It can be downloaded on Linux. Wherever you want, you can install. So wherever you have 2-core CPU, okay, 2 GB RAM, and you have 20 GB of hard disk, you can install it. Means on one single machine, you will have everything: worker, master, everything. But in general, we say this is what my master and worker node looks like. Master nodes count will be generally 1 and more than that. And worker node count will be 2 and more than that. If you say that in my production scenario, I had one master node, then the next question will be, if there is a failover, how are you managing it? Means if your master node fails, how will you manage it? So generally in production scenario, you have 2 master nodes and then n number of worker nodes. So there is no standard answer to this where you say that, okay, my 5 worker nodes were there, 2 master nodes were there. So there is no standard answer for that, okay? But you need to know how many masters, how many worker nodes you will go with. Simply don't say that I have 5 master nodes and 10 worker nodes. You should have a valid reason behind that when you state that, okay, I have these many master nodes and these many worker nodes. So the workload will decide how many masters are there and how many worker nodes are there. If the workload is more, I will have 1 plus master nodes. And if I have more workload, worker nodes will be also 2, 3, 4, 5, 10. But if you have only 1 worker node, there is a problem. A failover can happen, means the master node fails and then everything fails. So we try to avoid that. In a production scenario, we have more than 1 master node. Worker nodes can be anything. So let me start with the example where I have 1 master node and 2 worker nodes. In this scenario, the combination of this is known as cluster. It doesn't mean that if you have 3, it will not be called a cluster. Doesn't matter how many machines you have, master plus worker node combination is called cluster. Done. So if anybody says I'm working on Kubernetes cluster, then you will know what does that mean. It means combination of master and worker node. Okay, that is your cluster. When I say master node is majorly used for management related purpose. Okay, and when I say worker node will be majorly used for any work item, like some pod has to run or some activity has to be done. So that activity will be done on my worker node. Master node is also known as control plane because all the control or the management related work is done here. And the worker node is also known as minions. Generally, it is worker node only, but you will find at few places it is written as minions. Now, if I come back to my architecture, the first thing what you do is you start the interaction. Means you start to talk to the Kubernetes cluster. So if you say that I want to talk to the Kubernetes cluster, there are, in the diagram, there are 2 ways in which you can talk, but there are actually 3 ways in which you can talk. The first is UI or user interface. So generally what will happen, you will have a web console. Okay, and in that web console, you can log in and you can go ahead and see the things. So if I just come here, I'll also show you all these things, but it's just an introduction. So Kubernetes, Kubernetes, Kubernetes UI. So this is how my Kubernetes UI looks like. Sorry. Now, basically, this is my UI. And this UI will give me all the options like persistent volume, roles, cron jobs, pod, replica set. I'll explain all these things, but this is how your UI will look like. Anything which you want to do, you can directly do from here only. Okay, so that's your UI. I'll teach you how to deal with this UI and how to work with this UI. The second way to work with this is, okay, there are a few questions. Let me take 2 master and 4 nodes are interconnected. Everything is interconnected. So, sir, stop regarding questions for a while. Okay, let's stop then for 2 minutes and then take few questions. And then we can go ahead. I'm unmuting everyone. Anyone has a question, please go ahead.
I think, sir, you are not concentrating on well for explanation.
Give me some time. I'll explain it properly. Don't worry. Actually, I got another call also.
I think you are thinking in something in mind and then
No,
explaining.
no. Actually, there is a office work also parallelly going on. Anyhow, let me change that. Don't worry. Any questions here?
Yeah, because I asked right now the questions like you told two masters are there. So both are like 4 nodes are connected to one master, right? Like two
No, no.
masters.
All are interrelated. Means
Interrelated, right?
both
Okay.
the masters are related to each other.
Okay.
All the worker nodes are related to these two masters.
Yes. Okay.
Because so the same worker nodes can be connected with multiple masters.
Possible. Yes, possible.
Okay.
There are 3 ways to communicate. You said like one is through UI, the other one is through console, and the other one is.
No, wait. I have just explained one as of now. I'll explain the other two. I'm yet to explain the other two.
No.
So I have just explained this UI or the console. Let me continue. So the second way is kubectl. kubectl is the CLI or command line interface. So when I started my work, or let me say I just want to start my work immediately, I don't want to install anything. So Kubernetes.io, the official website of Kubernetes, provides me a console where I can go ahead and get my work started. So Kubernetes.io, just come and write interactive Kubernetes shell and you will get this interactive tutorial from where you can just come here and say that I just want to create a Kubernetes cluster and I want to start my work. You get a shell, something like this. Come here and say minikube start. So this is a Ubuntu 18.04 machine, comes with 2-core CPU, 2 GB RAM, and this much disk space. And here, Kubernetes 1.20.2 is getting installed. There will be components like kubelet, some RBAC certifications, control plane. So all these things are getting installed on my same machine. So I told there is something called minikube. So this guy minikube is getting installed. And this is coming from GCR or Google Container Registry. There is an image which is getting pulled and then it is done. Now here, I say Kubernetes is available. But to interact with Kubernetes, I am going to use something called kubectl. kubectl is nothing but it is kube for Kubernetes, CTL for controller. So there are many people who will say kubectl. There are many people who will say kubectl. There are few people who will say Kubernetes controller. So the full form of this guy is Kubernetes controller. Now here you say kubectl and then -- helm. Now you will get a list of commands which we are going to use. This is the list of commands which we are going to use in this entire training. As of now, if I come here and say kubectl get all, this is one of the commands. I'm able to see that some service is running. So coming back, I'll explain all these things, but coming back here, the second way is through CLI. CLI is your command line interface, the black and white screen. And through that, you can just log in and you can do whatever you want to do. But that is a CLI. So I showed you the front end. So this is the front end or the UI. I showed you the backend or the CLI. Now, there is a possibility that you can integrate your Kubernetes with some third-party tool. Okay. So if you have integrated your machine with some third-party tool, then you are using the third way of talking. And that is called API servers. Okay. So basically you're doing an API call. So in a generic scenario, I will say that there are 3 ways to interact with the Kubernetes cluster: UI, CLI, and API. Okay. So these are the 3 ways in which I interact with Kubernetes. Most of the time, you will see that we are interacting by this kubectl. This is the best and the easiest way to get started. Now, if I have to learn about kubectl, I don't know anything about kubectl. So I'll come here and say kubectl cheat sheet. Download any cheat sheet which you find and take a printout of that and just go through the commands. It's not like today only you practice everything, but at least you should know what commands are present. So I would recommend that you start learning these commands, because as and when we use it, it will become very handy for you. Alternatively, you can spin up a Kubernetes environment. I'll show you how to do it. I just now showed you one ready-made environment. Then just go ahead and say kubectl -- help, and you will get the entire thing available for you. So that is how we spin up a EC2, we spin up a kubectl environment. And these are the set of commands. Take anything which is suitable for you. This is good, bad. I don't want to get into that. So these are the three ways. Now, when you go inside master or the control plane, there are four major components. API server. This API server and the third-party thing is not same. Okay. So if I'm writing this API server, don't take that. This is API call I will put. So this API and this API, sorry. This API and this API are different. These two are different. Okay. So when I talk about master, in my master, I have four major components. The first component is my API server. Now, why do I need to know about all these things? Because tomorrow when you will be working and you will get an error, you must know what's happening inside, and then only you will be able to fix the problem. Else, you will not be able to fix the problem. You will not know what went wrong. So to understand what went wrong, I should know what is happening inside. Okay. So that's why I'm spending time to understand this. Now, the first component is API server. Now, API server is the gateway. Whenever a request will come, API server will authenticate that request, whether it is a genuine request or not. It will authorize that request, means whether the person who is making this request is authorized to make that request or not. So his authority and his authenticity will be checked, and this will be done by my API server. Or you can, in simple terms, say that it is like a gateway where the validity is checked, whether the user is a genuine user or not. If he is a genuine user, whether he has that power or not, he has that authority or not. In our example, we will be logging in as a root user, and you will get all the powers. Okay. But when you work on a prod scenario, definitely you will not get a root privilege, and definitely you will not have all the powers. So it will totally depend. You are joining as a developer or an administrator, and based on that, you will get the powers or the rights. Okay. But when I talk about components, API server is the first component. Here, all the requests will come, get validated, and then go inside. Okay. So API server is step number one for me. Is Rancher one of the third-party tools? Yes, Rancher can be used as a third-party tool. In fact, there are many such tools available in the market. So API server is my first guy. Then whatever you are passing from outside is your desired state, means you want to make changes. But first I should know what is already there. So this guy, etcd, is the actual state. It is a database, and this database will contain the current state of the cluster, means how many nodes are running. Inside that nodes, how many containers are running, which one is the master node, which one is the worker node, is the worker node available to take more workload. So all these things will be put inside those etcd database. So it's a key value database, key value pair database, where all the content is put. Okay. Then the third component will come, which is control manager. Now, control manager is the component which will receive the request from API server, because first the request came to API server. From API server, the request will come to control manager. Now, control manager will evaluate desired state and actual state. So let me say 3 services are running. There is a customer who is asking 5 services to run. It means 2 more services has to run. Now, how do I decide that? So this guy, control manager, will help me to take that decision. It will go to my etcd, check what is the current state, and then equate, or it will match the current state and the desired state. If both are same, no change required. Done. It will just say no change is done. But if there is a change required based on the match, it will go and give instructions to scheduler that go ahead and schedule this task or go ahead and do this task. So scheduler will go and talk to my kubelet in the worker node. So again, I'll explain this step by step. So the first activity which I'm seeing here is my API server. It acts like a gateway and just checks the authorization. So there will be something called RBAC, resource-based access control, by which I will allow root user to do everything. I will allow admin to do many things, but a developer will.
It is also called as role-based access control.
Same role-based access control, same thing. You give any name to that. So role-based access control will allow the users to go inside and do what they are supposed to do. So they will not get additional permission. So let me say I'm a developer. So I'll only get the rights to develop the code. I will not be able to go and make additional changes. As an admin, I will not be able to change the code. So that kind of limitations will be put by RBAC. First component. Once this is done, whatever request is coming, that is coming through my UI, CLI, or API, this thing, right? So that's called my desired state. Who will have that desired state? So control manager will have it. Control manager will have the desired state. The moment it has the desired state, it will also go to etcd to get the actual state. Means at this point of time, what is happening, how many machines are running and all those things. So etcd, it is also known as brain of the cluster. Means all the decision-making things will happen from here only because it contains the actual state. Now, based on what is the desired state, means what request came, and what is the actual state, a decision will be taken, whether both are equal or not. If both are equal means no action. If both are different means some activity has to be performed. Who will perform that activity? So that task will be given to scheduler, and scheduler will take that task to the worker node. So these are the 4 major components which we have in our control plane or master node. If you see here, it is only management related. It is nothing to do with the actual work. Okay. Now I'll take a pause here. Anyone having any questions here?
Is that master configuration will be done one time or whenever you want, you can customize?
One time. No, customization can be done anytime. But generally, when you do the installation, you do the setup. And changes can be done anytime. That is up to you.
And sir, are you going to explain deeply about the UI?
Yes. When we bring up our cluster or when we start our cluster, we will create our own cluster. That time I'll show you how the UI and all will look like.
How about the API calls?
API calls, we will do it via some third-party tools like Istio and all we will do.
Okay.
Because for etcd, can you tell one example kind of what are the key value pairs will be stored?
etcd, like, so let me say, if you see this diagram, I can see 2 worker nodes are there. So I have the visualization, I can say 2 worker nodes are there. But who will tell the control plane that 2 worker nodes are there? So here, there will be a configuration like worker node, something like this.
And so basically it is a database, no? That is.
It is containing all the details. So something like this will be stored. Suppose 6 containers are there.
Basically, information about the entire cluster.
Yes, metadata of the cluster, you can say.
Okay.
So based on the data only, we can take the decision whether it can be done or not.
That's why I'm saying it's the actual state, actually what is present there right now. So suppose my CPU is already 100% full. On top of that, you're adding another 5 items. How will it adjust? It will not be able to adjust. So there it has to decline. So to decline, it should know that it is already 100% full. So that is your etcd, the brain of the cluster. Okay.
So
If suppose
if the containers are getting increased or something, will the etcd says
Get
that
updated. It will get
get up?
updated. Always it will get updated.
So if we create the containers or something, and the etcd was already known that it is 100% full, then it will be allowed, or
It will give you error. It will give you an error.
okay.
See, the machine
and
is
do we
already
have any
100%
chances of
full.
increasing our memory, sir, by disturbing any master or workers?
No, you
for
have to
database?
increase the hardware capacity. Means you have to add additional RAM or additional storage.
It
That's
is
why
like buying hard
new
disk.
hardware, in case you are running it on your on-prem application. If you are running it on cloud, then automatically you can provision it on cloud environment.
But entire data, master data and worker data can be transferred, right, equally?
Yeah, that can be done. Transfer of data, migration of data can be done. That is not a problem. But suppose I'm running with 4 GB RAM. Entire 4 GB is full. I'm trying to push more workload. What will happen? It will crash. It will not be able to take that workload.
Correct.
So in that case, I want to run. So I'll increase the RAM size. I'll make it 16 GB. That's
Okay,
a hardware limitation.
Okay, so whatever the changes that has been made in the containers, will that API server will probe and get that into the etcd, or
No. Whatever is happening, wait, hold on. One thing which I'm making it very clear. Kubernetes is a container orchestration tool. Means anything related to management, that only will go and sit in my Kubernetes. What is happening to the container, what is happening inside the container, that stays in the container only. Okay.
Which will be taken care by the Docker.
It will be taken care by Docker volumes. Or
sir, in the Docker, other than the Swarm, everything is useful, right?
Yes, everything apart from that is useful. So you have here persistent volume. Okay. So persistent volume is there in Kubernetes also. Okay. So whatever volume concept we learned in Docker, we will be using it here also. But I am again saying Kubernetes is a container orchestration tool. So anything related to management will be taken care by Kubernetes. But anything which is happening to the container, the data inside the container, the working of the container, still Docker or the container will only take care of that.
It is kind of a guider, that's all. Nothing can be done.
Yes.
Because one question. So, see, Ansible we studied, it's kind of a configuration management tool.
Yes.
So if we have, say example in production, if we have a Kubernetes cluster with microservices running, so still do we need Ansible for the configuration management for managing the servers, or
Yes, you will. See, try to understand like this. I have people who know Japanese, the language Japanese they know. Okay. And I am a person who know English. So I will need a person who will translate English to Japanese. So the Japanese person will understand what has to be done and he will do. In my example, or in your example, Ansible is a configuration management tool, means it will spin up those servers for you. But Ansible cannot directly talk to Docker containers. So Ansible will first talk to Kubernetes via third-party API. Kubernetes will then talk to Docker containers, and Docker containers are the one who will actually do the work. Okay. So there is
Okay.
one thing, the work. There is second is management of the container. And the third thing is configuration management. So there are three different things here.
Sir, in production, what type of Docker we use? Simple command to run container, or Docker compose or Docker file?
You will be using Docker file.
Okay, so Docker file we have to use in production.
Yes, like how I did in Docker Compose, I went ahead, wrote a Docker Compose file. In Docker Compose, it was calling a Docker file. So that is how it works.
Okay, so Docker compose we use, right? In Docker compose we delete one container, so all container are removed.
Oh, that will happen.
So in this case, this is right. This is okay to use Docker compose.
Yes, it will be based on your, see, based on your customer's requirement, you will have to use it. See, if you see here in this, three containers are there, 1, 2, 3. The customer says, I want all three of them to run together. Then you will have to use Docker Compose. Okay. Anyhow, we'll come to that later. Now, I'm assuming that from control plane perspective, my thoughts are clear. What are the major components? Who will do what? The second component which we will be touching upon is my worker node. Who is a worker node and why we are saying it's a worker node and what are the components of that? So I'm repeatedly saying the worker node is one who will be doing the actual task or the actual work. When I come to the worker node, there are three major components: pod, kubelet, kubeproxy. Kubelet is a component which will take the request from master node. So I told scheduler will send the request. So scheduler is the one which will take the request from, so scheduler will take the request from my control plane and bring it and give it to kubelet. So kubelet is the one who will be taking the request and sending the response back to master node. So you can say kubelet is the agent which will help me to communicate. So if I come here, kubelet is the agent of communication between master node and worker node. So from master node, if some request is coming, some command is coming, then it will go to kubelet. And when the kubelet has to send the status back, okay, work is done, then it will be going via kubelet. Okay. So kubelet is the agent of communication. Then comes kubeproxy. Now, many times there can be a requirement that I directly want to talk to the worker node. So if there is a requirement, if I have to directly talk to the worker node, I don't want to come like this from master and then here. I directly want to come to the worker node, then I will use kubeproxy. As the word suggests, it's a proxy connection. It is like bypassing everything and making a proxy connection. So these are two things, simple, straightforward. Now, in the worker node, the most important thing is Docker runtime environment. It means that the Docker engine should be installed. If it is not Docker, then there are other tools, like in one of the release, which recently Kubernetes has done. They are saying that if you don't want to use Docker, you want to use something else, I'll support that. So here, Docker is not important. Okay. Here, Docker runtime environment is important, means Docker engine. Or if you have a machine which is similar to Docker, it gives you that virtualization thing that can also run. Now the question is, if Docker is not there, then who will be there? So if I say tools like Docker, I have Rocket, I have Ranches, OpenShift, Mesos. So there are many tools which are similar or are alternative to Docker. Like when I say that I'm going to take the code from Docker Hub, you will say, no, I don't want to take it from Docker Hub. I will take from Google Container Registry. I will take from Elastic Container Registry. I will take it from Nexus, I will take from JFrog. So like that, you have 10 different places where you can take the code from, right? Similarly, there are many tools which are equivalent to Docker. Okay, OpenShift, Ranches, and there are many. Hyper-V, VirtualBox, you have Rocket, like that. There are many other tools. So what in the recent release of Kubernetes has done is, it says, I need a Docker runtime environment. It is not mandatory that it should be Docker only. Any containerized environment is okay for me. You give me any containerized environment, I will be able to run those containers. Okay. So at least in India, I don't know about other places, when you say toothpaste, okay, and this comes up. So there are many people who will say Colgate. So early in the morning, you wake up, I want to use a toothpaste, I want to use Colgate. So many a times people use it like this: Colgate is equal to toothpaste, toothpaste is equal to Colgate, but that's not correct. Exactly the same thing is what is happening here. Many a times I say Docker runtime environment, Docker. Containerization is the correct word, but I keep using Docker. I keep saying Docker runtime environment. So Docker is there. Yes, Docker is supported, but in case you don't want to use Docker, you want to use some other container tool, containerized environment, that is also supported. Okay. Third and the last component, I have pod. Now, what is a pod? So pod is a layer of abstraction on top of my containers. So my Kubernetes clusters or my Kubernetes machine does not directly deal with containers. Means this architecture is not directly controlling the containers or directly talking to the containers. It is putting a layer on top of that, and that layer is known as pod. So I can say pod is the smallest unit of work in Kubernetes. Inside the pod, I can have containers. I can have 1 container, 2 container, 3 container, 4 container, 5. I can have any number of containers. It is up to me. So this Docker, which I'm showing here, is optional. These 3 containers, which I'm showing here, is optional. I can have only 1 container, and it will totally depend on your requirement, which software you want to use instead of Docker, how many containers you want to put inside the pod. So when you talk about only Kubernetes, remove this Docker from here and put it as container runtime environment. Remove these Docker containers from here, and it can be any container. That container can come from Mesos. It can come from Rocket. It can come from Hyper-V. It can come from OpenShift. So any container will be supported. Okay. So now I'll open it for questions. If you have any, please go ahead.
Hello,
yeah.
Yeah, because for in kind of OpenShift environment, so we will be creating a Kubernetes complete architecture with the clustering platform.
Yes.
In terms of Amazon or Google, it has the master service will be there, right? It kind of a managed service.
Yes, it is kind of managed service, and control plane will always be there.
Okay, so now during our studies, we will be learning how to create this cluster, right?
Yes, you will learn how to create the cluster from scratch.
Okay. Thank you.
Because can you explain this kubelet and kubeproxy one more time? Just in one.
See, kubelet is for communication. Master node is sending some request. Okay. I want to know what's happening. Okay. And sorry, kubelet will send and receive request from master node. So master node want to send some request here. So kubelet will receive it. Worker node has done the work. So kubelet will send it back. Then I have kubeproxy. Directly I want to connect to the worker node. So I'll use kubeproxy like that.
Sir, Kubernetes work with only when it is scheduled.
It has to communicate. Don't go by that. Say it has to communicate.
No. Even if I'm not doing without schedule, it will not go to the kubelet, right? The information.
This all things which I'm showing comes as a package. It cannot happen that etcd, I don't want, you take it. That does not happen. This complete architecture comes at one single packet. So if you're installing, everything will get installed. If you're not installing, nothing will get installed, like that.
No, I'm not talking about package, sir. In the work-wise, if you're not scheduling anything, then it will not go to the kubelet, right?
No, it will not. See, at the end of the day, if you don't
only when you schedule, it will go to the kubelet.
But see, if something has failed here in the worker node, then this worker node has to tell my master, right, that something has failed. How will it say? So kubelet can say. So it's a
in opposite direction, it will work. But until unless you schedule something new, then only it will indicate that kubelet to work.
That I agree. Yes. Yes.
Yeah.
So
if there is any failure in the pod, then kubelet will communicate to the master.
Yes.
Okay, kubelet will collect the information and give the desired state to the etcd, whether this many.
It will give to the master. In the master, it will go inside etcd. Like that.
Okay. Yes.
And sir, kubeproxy?
Kubeproxy, I told you, if you directly want to connect to the worker node. I have a requirement where there is something running in the worker node. I directly want to go to the worker node and see what is happening. I want to bypass all these things. So for that, you have kubeproxy.
Oh, that is also will come through scheduler only, or
no. I'm saying directly come to worker node. Scheduler and all is here. I'm saying directly come.
Means bypass means only it will have the read access to check the what happening in the worker nodes.
Will again depend how your admin has configured your rights. If it has given you edit rights, you can go and edit it also.
Okay.
Okay, I have a question about kubelet. So what kubelet can receive external requests only from scheduler, or can it receive external requests from anyone else?
External request kubelet will not be able to take.
So how is it communicating then? You said kubelet was for communication.
Communication between the master and worker node.
Yes, so you said it comes from scheduler, isn't it?
See,
the request.
Wait, I will tell you what's happening. There is two ways to communicate. The request comes all the way here. Via scheduler, it comes to my kubelet. This is one way. There is a guy who is directly trying to reach here. Okay. This is the two possible way. 1, 2. If you have an API who directly wants to come here, not possible. This is not possible.
Okay, but now you showed us only about UI.
Who can come directly? The guy who is not part of the master can come directly. If
he has a right to kubeproxy, then yes.
Yeah. Only until unless you don't have it, will not come.
Yes.
Okay.
And how about CLI? Because you said you just showed us about
whether
UI.
the request is coming from CLI, UI, at the end of the day, it will follow this path: API server, then control manager, then etcd, and then scheduler, and then it will go here. So here,
it goes through API server, then control manager, then etcd, and then scheduler.
Correct. That channel will be always there.
Sir, without kubelet and kubeproxy access, I can't access my container.
No, you cannot.
Okay.
Okay. So I will recommend all of you.
Pod is nothing but a production environment.
No, pod is a smallest unit of work in Kubernetes.
Yeah, but what is it exactly?
Pod is a shell which will put the containers inside itself. It's
which shell, like because there is so many.
You just think it's a packet. It's a container. I cannot use that word container.
Okay.
It is just a unit inside which all the containers will go and sit.
I understand, but how is it organized? Like, who decides which container goes into which?
Kubernetes will do all these things.
It just goes randomly.
Huh?
It just goes randomly to any point.
No. It will not be like that. When I will configure Kubernetes, I will show you how I'm going to map all these things.
So in the top layer, only the master node will through the scheduler, it will be concerned about only worker nodes with the kubelet, or in the outer part I'm talking about.
See, if you go by the channel, whether the request is coming from kubectl API server or API call or UI, it will first go to API server, then to my control manager, then to etcd, then to scheduler, and then to kubectl, kubelet. Okay. If that channel is working, you have rights, well and good, you go ahead with that. If you don't have, then you look for kube proxy server, kube proxy, if you have access to kube proxy. If you don't have that also, it means you will not be able to access your content.
Sir, put that notepad data in GitHub, no?
I'll post it. It is.
Sir, if we want to create any container, so we have to create through Kubernetes, right?
Container is different and Kubernetes is different. I am repeatedly saying Kubernetes is only for container orchestration, container management. Container
right.
is different.
So we are managing our container. We want to 4 to 5 containers.
The container is coming from Docker and the management part is coming from Kubernetes.
So we have to write command in Kubernetes.
Yes.
So
I will teach you that. kubectl is for that only. I will teach you that.
Okay, sir. Thank you.
Like because while we are logging, like we are executing kubectl commands, it is executing from master to the nodes, right?
Master to the worker nodes.
Yes,
Everything
master.
is happening on the master.
Like whatever the configuration we want to do in the containers, we need to go through the master, either or kube proxy, right?
Absolutely.
So don't forget to put the data into the GitHub.
So what I will do is just share the recordings with you. First, go through the recordings. From after that, I'll start sharing the content also with you, which will make things more clear for you. Okay.
Sir, Docker Swarm is called a Docker cluster.
No. Docker Swarm is Docker Swarm only. Docker Kubernetes cluster is the name given by Kubernetes. Docker Swarm is the name given by Docker.
And sir, what is Docker cluster?
There is nothing called Docker cluster. If you want that Kubernetes Swarm only, you give the name as Docker cluster. There is nothing called Docker cluster.
Okay, sir.
Fine. See you then, guys. Bye-bye.
So, sorry, when are you going to share it?